Hi everyone, this is the Ruby Book Club meeting, and today we are covering chapter 9, which is named Rate Specs, and chapter 10, which is named Construct Your Classes from Short Forecast Methods. So now there's this thing in programming people usually reference test-driven development. I'm still wrapping my mind around it. That thing whereby you write the tests and then you implement the functionality, and then after that you check to see if the test passes after you're done implementing the functionality. So this chapter 9 in particular, is about the ideas behind how you write tests specifically in Ruby. And first and foremost, the author starts with showing us how to write tests with the test unit library, which ships with Ruby as a programming language. And then after that, he transitions to showing us how to write tests with a popular testing framework, namely RSpec. And I think most of us have encountered RSpec. Maybe when dealing with Rails applications, most of them take to use RSpec, and then I think Minitest as well. So the test unit library, like I've said, it comes packaged with Ruby itself. And basically, you have a class. In this case, we've been dealing with the document class, I think, ever since the chapter 1 of the book. And we have code that is related to the document class, specifically the methods specified in a file named document.rb, right? It's a Ruby file. So to test the functionality of that class, using the test unit library, we create a file named document_test.rb. Document is the class name. And that is the convention when naming files that you're testing with the test unit library. You write the class name and followed by an underscore, and then followed by test, and then .rb. That is where your tests are going to live, or where you're going to write the tests. So how do you run these tests? Basically, go into RB and you write Ruby document_test.rb, and then the test runs. So when the test runs, it's usually going to bring you an output. If it passes, let's say you have 3 tests, the output is going to be like retest. I think it's going to tell you that 3 of them passed, and then it's also going to tell you whether those tests failed. That is, in case the tests failed. So going past that, we've seen that you write the tests in a test file, and then you run the test file. If the tests pass, you get output. Still, if the tests fail, you get a different sort of output. Are we on the same level when it comes to that? So moving on from that, we are actually looking at how to write the actual tests according to the test unit library conventions. So when you're defining a method in Ruby, you basically write def, which is a short form for definition, I think, and then the method name, and then the end. You end that method, of course. So similar to that, we see that when you're writing a test, a particular test that is testing for a specific functionality of, let's say, a class, you're going to write def, which is short for definition, and then you write test underscore, then the description of what the test is doing. And this is the convention for writing tests according to the test unit library convention. So you have def test, and then you write the description of what you're testing for, and maybe what you're expecting to see when this test is run. So putting everything together, we've seen that you write the tests in a test file, and the test file is named according to the convention whereby you have a class name, underscore test.rb. You run it by the same way you run any other Ruby file, by starting with Ruby, then the name of the test file, and then you get the output. And then we've seen how to write the actual tests. So we are going to look at I think, a few methods that are provided to us by this library, of which one of them is the assert, assert equal, whereby you're testing whether two things are equal. And if those things are equal, now let's say as part of a given test, if those two things are equal, the test is going to pass. But then if the two things you're testing for are not equal, the test is going to fail. And that is kind of the logic. So inside the method in quotes, or that the test definition you've written for that particular, I think, and if what you're testing for is equal to what you're comparing, then the test will pass. Otherwise, the test will fail. Then another thing to look at is that there's this thing whereby when you write a test or a test definition, you keep on repeating things that are not necessarily related to the actual testing. In this case, in the case of the book, this involves creating an instance of a given class, in this case, the document class. So according to the book, you can extract out that logic that you keep on repeating for every test definition, and you put it in a specific section of the test, or in this case, a setup method. And basically what the setup method does is that it checks while a test is being run, and it tells Ruby that before each of the tests in these test files are run, you need to do this and then run the test. And this setup method, I think it has an equivalent called the teardown method, which is called after each test is run. So when you have two tests, you're going to have the setup method called for the first test before running the first test, and then the teardown method called after running the first test. And then the setup method is called again before running the second test definition, followed by the teardown method being called again. And then, of course, as you don't have just the assert method, you have other variations of the assert method, whereby you have assert match, assert instance of, assert raise, whereby you're checking if the application is going to throw an error in case of anything. And in a nutshell, that is the kind of thinking around the testing, using the test unit library that ships with Ruby. You have a class that is defined in a file named according to that class, or what that class does, in this case document.rb. And then you create a test file for that class. You write your tests in there as method, I think, test definitions, because you're starting with the def keyword, I think, which is short for definition. You write your tests in there, and then you run the tests. And of course, you'll use these assert methods, assert equal to, assert match, to test the output of what running that code should result into. I don't know if we're at par.
Yeah,
Up until
I wouldn't get too hung up on the specifics of test unit, um, because there are other like RSpec. There are other libraries.
yeah, yeah,
RSpec and Minitest are probably going to be used a lot more than
mm,
the test unit
yeah,
library. But yeah, the tests are important, and you should be using them. You should be writing them. The documentation you should refer to is the documentation for that library. Probably not
yeah,
this book because it's so outdated. Um, And yeah, I agree. I use tests all the time, and tests are super helpful. Um, you mentioned TDD at first, and I do practice TDD. I think it is worth learning. I don't think you have to stick with it after you learn how to do it, but I do think it does help you get better at testing because if you're forcing yourself to do TDD, that means you're going to write more tests, which means you're going to get good at writing tests. And getting good at writing tests is a good skill to have.
Yeah.
Um, so, because writing tests forces you to design your code, you think of how somebody else is going to use it. And because you're thinking about how somebody else might use it, you make different choices on how to construct your code. Um, I think like code that is tested um, is going to be a little bit more flexible. There's a lot of things that you can do when you're not testing your code, where you have these big old functions that do a lot of things that rely on the internal state of some class to be present. Um, but when you're forced to write tests, your code is a little bit more flexible because you're just thinking about the inputs and outputs of some method, and it makes it easier to write a method that doesn't depend on so many other things. So on the rest of the state of your program. Um, Once you have those tests, it's easier to restructure your code. So if you're going to do any refactoring, um, for either readability or for speed, it makes it easier to know what you broke. Because there's, in a huge program, you change one class or one method, you can't always know all the things down the chain that it's going to affect. But if you write uh, your tests, then you know what you broke or what you need to change. Um, and then once you have all those tests, somebody else who joins your team can start reading those tests and understand what how the code is supposed to be used. So it's like basically document another form of documentation, and it's documentation that can't be wrong because these are literally tests that run the code and they either pass or fail.
Um, do you still use TDD? Because I think like in the beginning, it's good for you keeping like okay, I will try to test it and so on. But in the end, I think like the time that you take for developing is much higher than you try to develop first and create test later. I don't know what you think.
Yeah, I mean, I think so, but um, you're trading time here because you're trading time in terms of debugging in the future. So it might be faster in the present to go without tests, but in the future,
I don't mean like without testing, but
yeah.
it's like a test first and write code later.
Yeah, and then code second.
Yeah, for me, like you need to write tests. I agree with that, but like I don't see like it's something feasible for you. Always create the test first, and then you try to develop, and then you think like, oh, this test maybe is not. I changed something here in the code, so I have to write about the test. I think like TDD it's good for you like having the practice to write good tests, but like if you I don't think like it's a good or feasible to continue always doing that for the rest of your life. At least in my perspective, maybe someone does, but not me.
So I know myself, and if I don't write the test first, guess what? They're not getting written because I got the code. I got the I'll clean up the code a little bit, but you know what? I got these other features to implement, and guess what? I didn't write those tests. Whereas if I had written them as I was going along, um, then I just have those tests at the end. And yeah, it's slower, but for me it's like, well, if I put it off till it's the last thing I do, then then these borderline tests where it like, maybe I can get away with it now, of like not having those tests in because, oh, that method is so simple. Like I don't need to test that. It's so simple. It doesn't do anything. 6 months down the line when I'm changing something and I forgot, oh, that method is also used here and here and here, and I changed something. Well, if I don't have that test, well, it's fine. Like I changed something was simple, my code works, but some other part of the code base broke, and I made the
Yeah.
decision at the time to say like, no, I'm not going to test that stuff, and then just never got tested.
That's a good perspective because I think it's rare to know people that write tests first, at least in my, at least the people that I know. But for me, I prefer, at least for me, I prefer writing code and then writing tests because I think at least I see in the end, okay, I need tests for that, but it's just the way that I work better. But that's a good way to think to see life.
Listen, I
I would say
hate I hate writing tests. I
me too,
absolutely hate
me
writing
too.
tests. But you know what? It's like flossing your teeth, right? Like who has fun flossing their teeth? It's
Yeah.
a
Yeah.
chore. It's a chore
Yeah. You
and it
have to
helps,
do
and it's
it.
better for you in the end.
Mm.
Um, and but I also think that there is a perspective where it's like, you know what? I am going to experiment right now, and this is code that I'm just like I don't even know where I'm headed with this code. So like it's pointless for me to write tests right now. Let me just experiment a little bit, write some code, figure out where I'm headed with this, before I start writing tests. That's also a valid perspective. But then what you can also do is like once you know where you're headed, you can throw away all that code and then start writing tests. And uh, and when you start writing those tests, now you know where you're going, and you maybe the tests force you to restructure that code in a different way so that it's a little bit more flexible in the end instead of so intertwined and interconnected and hard to change later. Um, but yeah, I mean, I completely understand it. Like, if it were if and it's also the context, right? Because if I'm working on my own personal projects, whatever, it doesn't matter. Maybe I'm not going to write tests, right? If it's something for work and I have
Yeah.
to
You have
maintain
to
it,
write the test. Yeah.
yeah, I'm going to write some tests.
Just to add on a little bit about what you said, the personal project thing. So, as contributing to this open source project, and of course, they tell me I have to implement a feature. So I work on the feature and I push the PR like to the repo, and I want to get the PR merged. To me, locally, everything was working okay. I tested the feature localhost in the browser and it works. It wasn't until I wrote the tests that I actually discovered that adding that feature broke something somewhere else. And then I kept on making edits based on what the test is telling me. So you implement a test and then you check the stuff in the browser is working, but then the tests are failing. So that should tell you that there's something wrong with the code and you should be making edits along the way. But like Nelson has said, when it comes to personal projects, who cares? You don't need to write the tests. After all, it's going to be you looking at the code down the line. But when it comes to open source or maybe a job, I think given that other people will have to look at the code and given that the repository, maybe the code base is being worked on by so many people, you have to make sure that what you add doesn't break a section of the code that is worked on by someone else, because you'll be causing issues on their end. So I think that is how the tests help, or at least that's how I've seen they help. They help you make sure that when I add this, this doesn't break. As for the part of writing them before, maybe it's my skill level, but I'm not sure I can write those tests with the knowledge of what I'm going to, the software I'm going to write or the feature I'm going to implement after. I think for me, it works better when I first write the code and then I write the test and then I iterate from there. Like I check, is the test passing and is the functionality working, and then I go from there. So maybe it's my skill level, but TDD right now, very hard for me.
Yeah,
Very
for
hard.
if you're just starting out, if you're just learning
Yeah.
the language and the libraries, it's really hard to start doing TDD. That was one of the criticisms I had of TDD when I first started out. Is just like, listen, man, I can't even make this thing work. I don't even know why it's broken. How am I gonna start writing tests when I don't even know how, like, the I'm getting hung up on the syntax here. It was too much.
Oh yeah. So I think
Yeah, just one more thing that I'd like to mention. Uh, I never saw anyone using like test unit for testing. Usually they use like 80% use RSpec, 20% use mini tests. So
yeah. I think what the author was going for is that he tries to show you a before and after thing. So he shows you, remember, it's a book about Ruby, and he's trying to show you the internals of Ruby, what ships with Ruby, and how you can use it. But then, of course, what ships with something usually doesn't fit your needs. It's kind of like that thing whereby you have hot wire shipping with Rails, and some people just don't like it. They like Vite. But maybe the basics are the same. So I think what the author does here is he tries to show you a before and after thing, whereby he shows you the concepts from the test unit library that relate to RSpec. And I think his main argument about RSpec and why I think he covers it in this section of the book is because it brings in a more human readable quality to writing your tests. Like the tests read like English, as opposed to what you do with the test unit library. Because now let's say you have a test, RSpec tests start with they're wrapped in a describe block. You have a describe, and then now let's say describe document and then end. And then an individual test starts with it, do, and then end. And then inside that block, you define the exact steps through which the code should run or through which the test should run. And that is his main argument. It's just it reads like English, and that's why I think he kind of covers it here in this section of the book.
Yeah. The other thing I'll say is that this test unit library follows standards of other unit libraries. Like Java had a JUnit library. There was some other earlier one that was like SUnit or something, um, dating back from the 90s. But these these libraries, yes, they were used. But when Ruby came out, it set a new standard for writing tests, whereas basically expected that all your code would be tested and testable. And I think it's more important to write tests for such a like a dynamic language like Ruby, whereas Java you is a typed language, and you basically have protections built in your typed languages that basically say, oh, you're expecting this input, you're going to produce this output for this method. Well, Ruby doesn't have that. It's a lot more loosey-goosey, and something that might produce a true value. Like there's a lot of things that could produce a true value. The number one produces a true value, like a string "hello world" produces a true value. So if you're like expecting a Boolean to come out of this method, and you get like the number one, that's still truthy, and maybe the code works, but some went wrong there. Um, yeah, so I think in a dynamic language like Ruby, it's even more important to test things out.
So I'm saying we have like, is it 10 minutes?
Oh yeah,
I'm not sure, Nelson. Is it 10
yeah.
minutes? Yes, I'm going to kind of.
The second chapter
I'm going
always
to
gets
kind
a small amount of time.
Yeah.
Yeah. I don't know. Let me just, I don't know, speed run through the rest of the sections. Is that okay?
Yeah.
Sure.
Hmm. So I'm going to cover this section relating to stubs and mocks, and how they're related to the whole testing thing. So sometimes you're writing a test, and this test it needs to interact with other classes. Now let's say it's a test for a document class, like in the example given in the book, you're writing a test for the document class. But then this test, it needs to access, let me call it functionality or methods or classes that are that are belonging to, now let's say, another class. So in that case, what you do, you're going to use a stub. And what does a stub do? A stub gives you an object and provides you with methods of the class you need. In this case, by class you need, I mean the class that your test is depending on. It gives you an object, specifically an object instance of that class along with its methods. And you're going to use the provided object by the stub in your test to achieve what you're trying to achieve. And I think in the example given, you define a stub by using the stub method, and then you pass in the methods that you want to be made available to you as symbols. In this case, he passed in the available method, which I think is part of the print class. And then he also passed in the render method, as well as the arguments or the values of what those methods should return, respectively true and nil. So you use the stub method, you specify the available method, the methods you want to be available to you, and then you get an instance of that class, the class that you need. And I think this is basically helping you not to code that extra class that you need, or the class whose functionality you need. So the stub just gives you an instance of that class, and you use the instance instead of you creating a duplicate of the class, creating a new object for that class, and then using that object. The stub helps that way. And then a mock is similar to a stub, but then what a mock does, for a mock, you can actually engage with with the object more by calling methods on that object that has been available to you. And in this case, he calls no he writes a test whereby he checks and specifies that the render method should be called on the object 3 times, and the available method is called on that same object. And I think as part of the initial test, remember, when a method is run, the last line that is evaluated usually is the output of the method. And that is why you see that it checks that the final value or the final output of the test is the string, which shows that thinking was actually done. In a similar kind of manner, you check whether, if the printer is not available, you're going to return that string, which is telling you that the printer is not available. A mock is helping you to create a more specific test, which involves calling methods on an object provided by a stub. It provides you with the object, and you can use the object as, now let's say, as an argument to a given method that is in another class.
Is it just me or he froze?
No, yeah, he froze. He was
Okay.
he has network issues sometimes.
Oh, I froze.
Yeah.
Oh, sorry, which part did you guys get? I was talking about the stub and the mocks.
Yeah, that's it. We can continue from there.
Yeah, so in my own understanding, that is how I made sense of it. And then I don't know if Nelson, you remember that book club, the link you shared me with. They're covering this book called Ruby Science, and it has this part of the long method, like refactoring a long method. I don't know if you remember that. So,
I haven't gotten through that book yet, or
but
that
basically,
that
that is
resource.
what the next chapter deals with. It's telling you that you should break down a large a large method or methods in your classes into shorter methods that first and foremost do one thing. Like the method should do one thing, and then the name of the method should be descriptive. The method name should tell you what the method does, and then the method should also operate at a single conceptual level. And what it's doing, as opposed to accessing other methods and doing things that are out of the scope of what you need to do. First and foremost, readability. You just glance at the code and you can tell what it does, as opposed to having to look at and look.
Pedro, can you mute your mic? I think we're getting, yeah.
My mic.
No, you're fine. I was talking to Pedro.
Oh, yeah. So the importance of the short methods is first and foremost readability. You want to look at the code and make sense of it, at least in the shortest amount possible. As opposed to now, let's say you're going to have to chat GPT your way into understanding the code. And then for now, there are cases when I look at a method and I'm even way more confused after using chat GPT. So short methods can help you do that. You look at a method and it's easier to understand because it's short first and foremost, and it focuses on us on doing a single thing. And then its method name is descriptive. And then another thing or another way in which this helps is that when you're writing tests, instead of having a test that is spanning like, let's say 7 lines or 8 lines, you're going to have individual tests according to the short methods you have. And I think there's a section in that book whereby when he refactors that initialize method into smaller methods. You can see that he writes tests that are very easy to follow. Like the functionality is very understandable. You can tell what the test is doing. And when you refer to the code itself, you can actually follow that. This is what this code is doing, because you keep on calling methods at each, like now let's say there's a method and then you call another method that is at the bottom of the class. So basically, that is what this chapter was about. You get the class, and instead of having like very giant blocks of code, you break that code down into very small focused methods that whose names are descriptive and that perform a single thing instead of many things at the same time. And like I've mentioned, why do we do this? Easier to test, code is easier to understand, and also it's easier for someone to pick up from where you left when they join the team. Now let's say you're working on an organizational code base. It's easy for someone to pick up. Yes, so that was my speed run. I don't know if I was too fast or
Yeah. No, it's also easier for me to pick up because there's been times when I'm like, I write the test and it's the last thing I write, and I realize, oh, I don't have time to write I got to go home. I don't have time to implement this thing. So Monday comes around and I run the test. I see what failed, and I'm like, oh, yeah, that's where I was. I got to write the actual code for this failing test. Okay, great. So it helps me get back into place where I left off.
Yeah, so I think that is all for these two chapters. So far we are going like we are about, I think, to get done with the book. We've made some progress. I think this is chapter 10.
Yeah.
Yeah. No, I think you froze again.
Yeah, so I don't know if you guys have something to supplement.
Um, I think like when you're programming with Ruby, uh, probably you're gonna implement like some kind of linting, some kind of rules. The man is Robocop, and he have like some rules that you can specify. One of them is having like a method should not have more than 10 lines. I think it sometimes is a little bit strict. You can have like you don't need like to focus on 10 lines, but I think it's a good way to start at least. I like the idea of you writing like a small methods with few lines that can be called by each other and then form like the the final output. I like this way of do, doing Ruby things. So I think that's what I have to say.
Yeah, they did talk about using mocks and stubs, and I would say don't use them at first. There are places where they should be used, and that's for like, you're doing some network request to an external API or something like that. So you don't want your tests connecting to external APIs. So that's a good use case for using mocks. But if you're using mocks just as a regular practice in your code, then what ends up happening is that that benefit that you used to get, where it was like, oh, when something broke, all the places where it broke. Well, if you start using mocks, then guess what? It's not testing the real classes, so you don't end up finding out that it broke something else if you're using mocks. So I would limit the use of mocks and 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 only use them when they're really needed.
Yeah, I agree with that. For instance, here where I work, they have like a large suite of testing. So we have like factory bot implemented, and when you create a factory bot, usually the creates like the object